Hi all, this is my fourth video and my last video from section 7.2, and we're going to talk about critical values. Now when we use the word critical in math, we're talking about a point where we transition from one state to another state. In medicine, they mean it in exactly the same way. When they're talking about condition critical, the two states that they're talking about are the state between life and death. If the situation is critical, you're at that possible transition point, and hopefully we won't transition into the other state, but we're at that point is what makes the situation critical. Now, back to math, we already have been talking about a cutoff value, the place where we transition from usual to unusual, probable to improbable. Let me write that on here. Probable on one side of the boundary, improbable on the other side of the boundary. Or we can talk about the value where we transition from what could be likely to what would be unlikely. And we call this point, this transition point, is what I'm talking about when I'm talking about a critical value. Now, we have been talking about the critical value being the boundary between 95% probability, that's probable, to 5% probability, which we call, if there's only 5% probability left, we call that improbable. And we think this occurs at 2 standard deviations above the mean or below the mean. Notice how I worded that, though. We think this occurs at the 2 standard deviation mark. We are in fact wrong. So let's look at that. So the most common values, the most probable values are in the middle. I'm at the bottom of the screen here. Let me see if I can transition that just a little bit. Slide this down if I can. Nope, doesn't want to slide down. Hang on. So the most probable outcomes are in the middle. So here's my improbable. This is improbably high. And these are improbably low. And in the middle, I've got 95% of all of the outcomes, 0.95. So in the combined tails, we have 5%. But that means 0.025 in each tail. It's symmetric, so we'll take that 5% and divide it in half. Okie dokie, let's clear the screen here. So let's have another look at that picture, the one that I've just erased. Sorry about that. If I've got 0.95 in the middle, and I've got 0.025 here and another 0.025 here, then I'm trying to find these cutoff values. And we're going to call these critical values, we're going to call them Z sub alpha. That is the Greek letter alpha. Let me draw it in a second, but this thing is the critical value, and it's the positive of the two. Remember here that the middle here is 0, so all of these are negative, all of these are positive. That means I'm talking about this guy is going to be the positive critical value. That's because this guy here is exactly the same value as this guy, except negative because of symmetry. So let's actually find this guy. oh, hang on, I was going to talk about alpha. Sorry about that. So alpha, oh no, don't start. Alpha, this is another one of our Greek letters here. I've had students call it the fish, and I don't mind. Alpha is the significance level. And we will talk more about the significance level, but in this context, we're talking about the significance level of usually the significance level is 5%, 0.05. So in this context, we're talking about 95% in the middle and 0.025 in the tails. And so let's go ahead and find the negative of the critical value, Z1. Why? Because it's easier. Because remember, I can do inverse norm of area to the left, and I've already computed what area to the left is, 0.1. And so that will give me negative 1.96. And because of symmetry, so this is 1.96 below the mean, so this thing must be 1.96 above the mean because the center is at 0. So the positive z value, also known as our critical value, z sub alpha, is equal to positive 1.96. So that made it easier to find. So it turns out that we're not talking about 2 standard deviations above the mean or below the mean. Let me clear the screen here and make this point. The z-score tells you how many standard deviations you are above or below the mean. So if the z-score is negative 1.96, you are not 2 standard deviations below the mean, you are 1.96 standard deviations below the mean. And if the z-score is 1.96, you are 1.96 standard deviations above the mean. Now, I agree, 1.96 does round to 2, so 2 was close enough. And we could say that if you were 2 standard deviations above the mean, that will be our cutoff for usual or unusual. But from now on, we need more precision. Okay, so let me give you the payoff and then we're done with this video. We will need to define the usual values usual values as this window. The mean minus 1.96 standard deviations on up to the mean plus 1.96 standard deviations. That is if our significance level is 0.5. If it's really critical, if it's really important that something not happen, like if this happens, people could die sort of thing, like if the radio on an airplane fails, we want that really improbable. And we lower the significance level which you can kind of see why I would like to abbreviate that as alpha, then we'll need to recompute, which we will do in Chapter 8. So I will see you in Chapter 8. Thanks for watching my Chapter 7 videos.